The universe is a place of endless mystery, from the swirling galaxies billions of light years away to the unseen particles dancing in the quantum foam. Reality constantly reminds us that what we know is but a sliver of what exists. For centuries, one cosmic enigma has haunted human imagination more than any other: the black hole, a region of space where gravity is so intense that nothing, not even light, can escape. A one-way door into oblivion, a dark, endless pit devouring everything in its reach. But what if black holes are only half of the story? What if, hidden somewhere beyond our grasp, their mirror opposites exist? Strange, radiant phenomena that do not pull matter in, but rather spit it out. These are white holes. Theoretical cosmic objects predicted by the same mathematics that gave birth to the idea of black holes. Yet while black holes are now accepted as real, white holes remain a mystery. Perhaps myth, perhaps something waiting to be discovered. And if they do exist, they could be key to understanding the very fate of the universe. To truly appreciate the bizarre concept of white holes, we first need to understand how their darker siblings came to be. In 1915, Albert Einstein unveiled his theory of general relativity, a groundbreaking framework that described gravity not as a force, but as the warping of space-time itself. Under this theory, massive objects like stars bend the fabric of space-time, creating the familiar sensation we call gravity. Shortly after Einstein's theory was published, a German physicist named Karl Schwarzschild found an exact solution to Einstein's equations. This solution described a point in space where gravity becomes infinite and space-time curves infinitely inward, a singularity. Surrounding this singularity would be a boundary called the event horizon, a point of no return. This was the mathematical birth of the black hole. But interestingly, Schwarzschild's solution also implied something else, something few people noticed at the time: a mirror image of the black hole. Instead of pulling matter in, this object would eject matter outward. An explosion frozen in time, a white fountain of energy and matter, a white hole. At first it seemed absurd. After all, black holes made sense. We could imagine a star collapsing under its own weight, creating a singularity. But how could a white hole form? Where would the matter it expels come from? For decades, white holes remained nothing more than a mathematical curiosity, a bizarre consequence of equations nobody believed could exist in the real universe. But the deeper scientists probed into the fabric of reality, the stranger things became. White holes, according to theory, would be utterly different from anything else we know. They would be regions of space and time where nothing could enter, only exit. Imagine a river flowing backward, a waterfall in reverse. No matter how hard you try, you can never approach the center. You are always pushed away. If black holes are cosmic traps, then white holes are cosmic fountains, repelling all matter, light, and energy. The idea sounds fantastical, almost magical. And yet, as our understanding of the cosmos deepened, white holes refused to vanish from theoretical physics. In fact, some scientists began to wonder, could black holes and white holes be two sides of the same coin? One of the strangest ideas to emerge from modern physics is that of wormholes, hypothetical tunnels connecting distant regions of space and time. According to some solutions of Einstein's equations, if you connect a black hole to a white hole, you get a wormhole, a passageway through space-time itself. In this vision, black holes are entrances and white holes are exits. Matter falling into a black hole might emerge somewhere else in the universe, or even in another universe entirely, through a white hole. Such wormholes, if they exist, could allow for faster-than-light travel, time travel, and other mind-bending phenomena. But wormholes, like white holes, remain theoretical, tantalizing ideas without direct evidence. Still, the possibility refuses to fade. Over time, new theories have given white holes new life. In the strange world of quantum mechanics, nothing is truly forbidden. Particles can appear from nothing, tunnel through barriers, and violate our everyday expectations. Some physicists have proposed that white holes could arise spontaneously through quantum processes in the early universe. Perhaps in the moments after the Big Bang, countless white holes formed, ejecting matter and energy into space. Maybe, just maybe, some of them still exist, hidden in the vast, dark wilderness between galaxies. But even more mind-bending possibilities arise. What if black holes themselves eventually become white holes? This idea, called black hole to white hole transition, suggests that after a black hole evaporates through a process known as Hawking radiation, it might not vanish completely. Instead, it could transform into a white hole, spitting out all the matter it once consumed, like a cosmic rebirth. If true, it would mean that nothing is truly lost in a black hole, only delayed. Information swallowed by a black hole might eventually re-emerge from a white hole, preserving the fundamental rules of physics. Such a process would solve one of the greatest mysteries of modern science, the black hole information paradox. Still, all of this remains speculation. No white hole has ever been observed. No clear evidence exists. No light, no radiation, no signal shouting, "Here I am." And yet the mathematics is sound. The possibility is real. Some astronomers have even speculated that certain mysterious cosmic events, sudden, intense bursts of energy like gamma-ray bursts or fast radio bursts, might be glimpses of white holes in action. A white hole would appear as a sudden, brief flash of energy, exactly the kind of phenomena we sometimes see and cannot fully explain. Maybe the universe is littered with dying black holes turning into newborn white holes, erupting in blinding flashes of light before fading into silence once more. Or perhaps white holes are even more exotic. Perhaps they lie beyond our cosmic horizon, in parts of the universe we can never reach. Perhaps they exist only in parallel universes, places we will never know. Or maybe, most chilling of all, they are closer than we think. Maybe the ancient cores of dead galaxies hide silent white holes waiting to awaken. The idea that white holes could exist is already mind-bending. But what if the truth is even stranger? What if white holes are not just rare cosmic oddities, but the very reason we exist? To understand this, we must dive into one of the boldest and most thrilling ideas in cosmology. The Big Bang itself might have been a white hole. When we look at the universe today, we see galaxies rushing away from each other. Space itself is expanding, stretching the fabric of reality outward in all directions. When we run this process backward in time, it leads to a singularity, a point where the universe was unimaginably hot, dense, and small. This is the Big Bang, the birth of space and time. But here's the twist. A white hole, according to theory, is also a singularity, surrounded by an event horizon, just like a black hole, but in reverse. Instead of matter and energy collapsing inward, a white hole erupts outward, creating new space, new matter, new energy. Sound familiar? In some models of the universe, the Big Bang can be seen as the ultimate white hole, a cosmic eruption that didn't just happen in space, but created space itself. If this is true, then every galaxy, every star, every atom, including you and me, might be the result of a white hole's explosion billions of years ago. It's a radical idea, and one that challenges the way we think about beginnings and endings. But it gets even wilder. Some physicists have proposed that every black hole might give birth to a new universe inside it. Imagine, when a massive star collapses and forms a black hole, the singularity inside could actually spawn a new Big Bang, a new universe with its own dimensions, its own stars, its own laws of physics. From the outside, we see a black hole, but inside, a whole new cosmos might be expanding, disconnected from ours. In this view, black holes are not just cosmic dead ends. They are cosmic seeds, creating baby universes through white hole bursts on the other side. This theory, sometimes called cosmological natural selection, paints a breathtaking picture. Our universe might itself be the offspring of a black hole from a parent universe. And within our universe, every black hole could be a portal to new universes yet to be born. Life itself might be the result of this endless cosmic cycle of death and rebirth. Of course, this remains highly speculative. We have no way of observing what happens inside a black hole, at least not yet. And the true nature of singularities remains one of the greatest unsolved mysteries in physics. But the implications are profound. If black holes lead to white holes, and white holes create new universes, then reality might be an infinite, ever-branching tree of worlds. A multiverse beyond imagination. Each universe might have slightly different physical laws. Some might be empty and lifeless. Others might teem with stars, planets, and civilizations. Maybe, just maybe, some distant black hole right now is giving birth to another universe where different versions of us are asking the same questions, looking up at alien skies, wondering how everything began. But even if we set aside the wildest ideas, white holes might still play a critical role in our understanding of the cosmos. For decades, one of the thorniest problems in physics has been the information paradox. According to quantum mechanics, information about physical systems can never be destroyed, but black holes seem to destroy information, swallowing matter and energy without a trace. This has troubled physicists for years. If white holes exist, they might provide an elegant solution. Instead of losing information forever, a black hole could eventually transform into a white hole, releasing the trapped information back into the universe. In this way, the balance of nature would be preserved. Nothing is truly lost. Everything finds a way back. Even death is not the end, only a gateway to new beginnings. Still, enormous questions remain. How stable would a white hole be? Would it collapse instantly under its own pressure, or could it survive long enough to influence the universe? What signals would a white hole produce? Could we detect one with our telescopes, our satellites, our eyes turned to the heavens? Scientists are beginning to hunt for answers. Some believe that mysterious phenomena like fast radio bursts, sudden, powerful pulses of radio energy from distant space, might be linked to white holes. Others suggest that unexplained gamma-ray flashes could be white hole bursts, but evidence remains elusive. White holes, if they exist, would be rare, brief, and incredibly hard to observe. They would erupt with enormous energy, then vanish, leaving little trace behind. In fact, some theorists argue that the very act of observing a white hole might be impossible. Because of the way space-time bends around them, a white hole's event horizon would be an impenetrable wall. We might see the effects of a white hole's eruption, but never witness its core. Like a cosmic magician, a white hole would reveal its tricks only in glimpses. Flashes of light, bursts of radiation, ripples in space-time. And yet, the search continues. Across the globe, massive projects like the Event Horizon Telescope, the Laser Interferometer Gravitational Wave Observatory, LIGO, and the upcoming space-based LISA mission are pushing the boundaries of what we can detect. New generations of telescopes and detectors may someday catch the first glimpse of a true white hole. Until then, white holes remain one of the universe's greatest secrets, a tantalizing whisper from the unknown, a reminder that reality is far stranger and far more beautiful than we can imagine. The idea of white holes opens doors into possibilities so vast and strange, they almost feel like science fiction. But in the final part of our journey, we'll go even deeper, into theories that could forever change our understanding of time, space, and the ultimate fate of the universe. First, let's talk about time travel. One of the most fascinating properties of white holes is their relationship with time. Black holes warp space-time to such an extreme degree that for an outside observer, time near the event horizon slows almost to a stop. White holes, in theory, do the opposite. Because nothing can enter a white hole, only exit. Its very structure implies a reversal of the black hole's timeline. Some physicists suggest that a white hole could be seen as a black hole traveling backward through time. If this is true, it has breathtaking implications. White holes might not just be cosmic phenomena, they could be gateways across time itself. In theory, if one could survive the extreme forces at the mouth of a white hole, a near impossibility, it might be possible to travel to different eras of the universe, or even into parallel timelines. But the practical obstacles are colossal. The energy levels involved would vaporize anything that came close. The space-time around a white hole would be wildly unstable. And even approaching a white hole might require technologies far beyond anything humanity currently dreams of. Still, the idea lingers, a shimmering possibility in the minds of theoretical physicists. Maybe, just maybe, the universe has already hidden its time machines in plain sight, disguised as the most violent phenomena in the cosmos. But time travel isn't the only cosmic secret tied to white holes. They might also offer an escape from the death grip of black holes. One of the terrifying realities about black holes is their finality. Once you cross the event horizon, there's no coming back, or so we think. But if black holes are linked to white holes, if they are two sides of the same cosmic coin, then perhaps falling into a black hole doesn't mean total destruction. Perhaps under the right conditions, you could be ejected through a white hole, reborn into a different region of space, or even into a different universe. Imagine a spacecraft caught by a black hole's gravity, ripped apart, only for its particles, its information, its essence to be flung outward through a white hole somewhere else, sometime else. It sounds like fantasy. And yet, in the tangled mathematics of general relativity and quantum mechanics, it's not entirely ruled out. This idea ties into another profound concept, the conservation of information. As we discussed before, one of the great puzzles of black holes is what happens to the information they consume. Quantum theory insists information can never be destroyed, yet black holes seem to erase it. White holes could solve this paradox. By eventually ejecting all the information swallowed by a black hole, white holes would preserve the cosmic ledger. Nothing would be truly lost, only transformed, hidden, waiting for release. In this way, white holes would serve as guardians of cosmic memory, ensuring that the universe never forgets its past. But the most astonishing role white holes might play is far grander, tied to the fate of the universe itself. Our universe is expanding. Galaxies drift farther and farther apart. Stars burn out, and dark energy accelerates the cosmic stretching. If nothing changes, this leads to a bleak future, a cold, dark, empty universe, the so-called heat death. But what if white holes change that ending? Some theorists propose that, in the distant future, when black holes have consumed most of the matter in the universe, they will begin to decay, evaporating through a process known as Hawking radiation. And in the final moments of their evaporation, black holes might not just fade into nothingness. Instead, they could explode into white holes, releasing all their trapped energy and information back into the universe. This would flood the dying cosmos with new light, new particles, new possibilities. Rather than ending in silence, the universe would experience a final, glorious burst of creation, a rebirth from the ashes of its ancient past. In this vision, white holes are not just exotic oddities. They are the engines of cosmic renewal. They are the phoenixes of the universe, burning bright after death, ensuring that something new always rises from the old. It's a beautiful, haunting idea. Of course, all of this remains unproven. White holes have never been directly observed. They exist for now only in the equations of Einstein, the imaginations of scientists, and the dreams of those who dare to look beyond the horizon. But science thrives on mystery, and the search for white holes is part of something greater. Humanity's endless quest to understand where we came from, where we are going, and what astonishing wonders still await us among the stars. Maybe one day, we will see a white hole with our own eyes, a cosmic geyser of creation, painting the darkness with new light. Maybe we already have, without knowing it. Maybe in the endless dance of space and time, every end is a beginning, every fall is a rise, and every black hole is secretly a promise that nothing truly ends, that the universe always finds a way to begin again. And maybe, just maybe, we are all children of a white hole, carried across the eons by the unstoppable fire of cosmic rebirth. The universe is not silent. It speaks in explosions of light, in rivers of time, in the strange and beautiful dance of black holes and white holes. And if we listen closely, we might just hear the whisper of new worlds waiting to be born. If you enjoy this journey space in time possibility, don't forget to like, subscribe, and share. Until next time, till looking up, the universe is waiting.